by Mr. Baccio AF, Senior Research Engineer Capable. Mr. Baccio AF is a seasoned industry expert with over 7 years of experience in manufacturing, electric vehicles and automotive industry. His career highlights include Research Associate at ANK Industry, Indian Army led defense vehicle engineering projects showcasing deep expertise in the sector, Director at ANZ Automotive, founder of Reading Tissues, an established company specialized in production of tissue paper and hygiene products. He's a versatile professional with a strong background in both technical and leadership roles across multiple industries. I welcome you, sir.
Thank you. Thank you so much. Really a warm welcome. Really good. And first of all, thank you for the Jyoti College who invited me as a research person to just address you for some future technologies in automotives. Really thank you. Good. And next is like what we'll do. We have around 2 to 2.5 hours, right? In this 2 to 2.5 hours, we can do a small split up. In this 1 hour will be inside seminar hall, and another 1 or 1.5 hours will be hands-on practicals. Is it good for you? So 1 hour will be inside seminar hall, classes will be there. Another 1.5 hours will be on electric vehicle. A basic electric vehicle will be shown to you. From there, all the things will be taught to you, like this part is this part is this. Whatever I am teaching in PPTs, you can see there in hands-ons. Good?
Yeah.
Clear? Nice. Because whatever we are teaching you in papers, if you can't see in pictorial things, means you can't for sure get into it. Okay? Good. And one more thing, this 1.5 hours should be an interaction session. It should not be a one-way process. I'll be asking some questions to you, and some of the faculties are also here, senior most than me. Just allow me to ask some questions to you. This 1 hour should not be a sleeping classes. It should be interaction session with me and you. Done? Good to go? No sound is there.
Yes.
Again, no sound is there.
Yes.
Good, nice. Everybody had breakfast, right? Anybody didn't have breakfast? Good, nice. And can we switch off these lights?
Okay, sir.
Good, sir, good. And first and foremost, any idea about history of electric vehicle? In which year it got founded? Any idea? Do you know that when IC engine founded?
1870.
IC engines, 18th centuries, 1870s. And what about electric?
Yes, before that.
Any idea about years? 1856, 1850s something. Okay. This is the history. Is it everybody clear about it? In 1831 the research was started. On road, after 1880 on road it came. So before IC engine, electric vehicle was formed. So this is just a small history about it. You can just go through these things. And next, what we'll do, we'll go for a small connections of an electric system. A basic connections of electric system. There is a basic two connection systems. One is series, and another one is parallel. Okay. This is an example of, like, these are the things: electric circuits, closed versus open circuits, series circuits, parallel circuits, circuit diagrams. Okay. This is actually electric circuit. Basic components of a circuit. What connection does this have? Is it DC or AC? What connection does this circuit have? Is it a DC or AC? AC or DC? DC means how? What? What? Okay, AC is also going positive negative. What is actually DC and AC? Abbreviation of DC and AC. Direct current, alternative current. What actually direct current is happening in AC? What is happening? Any idea about how the AC connection is going on? What is the idea about DC connection is flowing off? Just flowing through the circuit. Everybody is having iPhones, right? Everybody is having a good slow motion cameras. Did anybody tried in your house just focus an electric bulb in a slow motion? What will happen? Did anybody try? What? It will flicker. Why it's flickering? It's AC, right? Per second, the connection will be coming and going out. There won't be a continuous current. There will be a stoppage of current in seconds, fraction of seconds. That is called as AC. That AC will be happening in high voltages only. But in DC, whenever the voltage is low, we are just opting for DC. Whenever the power to weight ratio is a thing called a person who's weighing 50 kgs, he need to have to move itself, he need to have consumed some foods, right? Is it the same for a 100 kg person? Is it the same for a 100 kg person? No, right? So there will be a food consumption difference. The same in electricity. Current is carried by voltage. Clear? This is a DC circuit. Next, this is a closed versus open circuit. This is a closed circuit. If the switch is taken off, it's a closed circuit. If a switch is just on, it's an open circuit. It's closed circuit versus open circuit. This is a series circuit. From battery is a power source. From the battery, if a series connection is going on, like from one end it's starting and ending in another end, means with the one point it's called as a series connection. The same current flows through each components. It doesn't have any different components. Clear? A real world example is of a kettle. A kettle. Next, this is a parallel circuit. With the same power source, if you are doing a two operations, it's called as a parallel circuit. Clear? With the same power source, whether is it getting glad or whether everybody is glad? No. do? No, actually it's projector's light only, it's reflecting. Just adjust it. Nothing can be done. So this is a parallel circuit. From a same power source, two different options is like operations is done is called as a parallel circuit. Example, a real world example is of a car headlights. If one car headlight is off, another car headlight will be on. Right? You have seen. Everybody, like anybody drove cars. Which year you are? Everybody, which year you are? Final year?
Yes.
Everybody is final year. Okay. Anybody driven car?
Yes.
If one light is gone, if one fog light is gone, another fog lights will be working, right? That is called as a parallel connection. So, for a one light, from a battery, a connection will be gone. From another light, a battery connection will be gone. Okay? That is called as a parallel circuit. This is a series versus parallel circuit. If a wire breakage is happening here, or a wire breakage is happening here, this both lights won't work. This is called as a series. Here, if a wire breakage is happening here also, if a wire breakage is happening here also, the two wires separately, one light, at least one light will be glowing. Okay, that is called as a parallel circuit. This is a circuit diagram of it. Whatever you have seen, it's a circuit diagram of it. And this circuit diagram symbols. Whenever you are just creating a diagram on papers, you need to notify these symbols. Okay? See, this is a real time of circuit diagram. For load bulb, it's X, and switch is having 2 poles, and the power source is having a dotted lines. Clear? This is the basic connections. Without this, we can't go for other connections also. So I'm just touching this, a quick touch, and next. Right now, coming into the topics. Classification of electric vehicles. Okay? Everybody know about a real-time, like Toyota Camry car. Everybody know about Toyota Camry car. Do you know how it's working? Any difference between a normal car and a Toyota Camry car? Any difference between a normal and a Toyota Camry car? Any idea? What is the difference between, like right now, everybody know about urban cruiser, Toyota urban cruisers. Is there any difference between a normal car and an urban cruiser? What? What type of hybrid is that? Any idea? It's a hybrid car, but in classified things, what type of hybrid? Anybody? Any idea? What? Huh? It's having both. Hybrid means you are just making a IC engine and a battery power plant. Come on, say once again.
I think, not sure about it. They are using
Yes, yes, yes. Okay. And right now I'm again creating a classification like what is the difference between, you know that all Maruti cars, Maruti Suzuki Nexa cars are hybrid cars, right? You don't know. All Maruti Suzuki Nexa cars are hybrid cars. Okay. What is the difference between urban cruiser and Maruti cars? Both are hybrid.
It's plug-in electric.
Sir,
It's plug-in.
which one, sir?
That's urban.
Ah. Actually, these are the classifications. Parallel hybrid, series hybrid, actual hybrid. Okay? One more classification is there, plug-in hybrid. In plug-in hybrid itself, there are more classifications as of now. Like smart hybrid, micro hybrid, macro hybrid. Okay? In plug-in hybrids, what and all is there means like Maruti Suzuki cars are using a smart hybrid and a micro hybrid. Whenever your car is standing idle, that means whenever your car is on 1000 RPM, less than 1000 RPM, it will run on electric motor. Everybody know about alternator, right? What is actually alternator doing? Converting the perfect, good sir. Converting the mechanical energy into electric energy. Okay? Through that alternator only, each and every vehicle's batteries is again charged. Okay? So, with this technology, what Maruti Suzuki cars done means, they done a bigger battery pack. Whenever if you are going for Maruti Nexa like Ciaz and Ignis, France and all, if you are buying it, if your battery is worn, you need to spend more than 5,000 to 6,000. But normal cars doesn't have that much. 3,000 is enough. What is the difference between that car and this car is like, they'll be giving a bigger battery pack. The alternator, whenever it's running more than 1500 or 2000 RPM, the alternator start to generate more current to the battery for the charging purpose. Okay? From that charging purpose, whenever the vehicle is coming below 1000 RPM, battery will power the wheels. The alternator will act as a motor. That is called as a micro hybrid, macro hybrid. Through this, you know about Maruti cars, how much mileage they used to give. Before this technology, they gave around 20 km per liter. With this technology, they climbed more than 27 km per liter. With the small changes, they climbed more than 7 km per liter. This is the difference what hybrid is giving to us. This is the difference what electric power is giving to the automotives. Clear? This is a micro hybrid and a macro hybrid. Right now coming into Toyota Camry. This is plug-in hybrid. Plug-in hybrid is exactly 4 wheel is powered. The micro hybrid is powered with 2 wheels only. Front wheel is fully powered. But this plug-in hybrid, 4 wheel is powered. Front is engine, rear is electric motors. It's smart switches. Where in urban cruisers, in Brezza urban cruisers and all, doesn't have any switch to switch from electric to engine. It's a smart switching power. Okay? Whenever you are in city, electric will be working. Whenever you are in highways, engine will work. The same concept, whenever the engine is run, battery is charged through alternator. This plug-in hybrid battery, so only Toyota Camry is very costly. Toyota Camry's base variant is around 30 lakhs. Because of engine and a battery pack. This is called as a plug-in hybrid. See here. Here, IC engine is there, regenerative braking is there, electric motor is there, battery is there. Through braking also, everybody know about Mahindra Reva car, a small, cute car that 3 persons can sit easily. It's a city purpose, Bajaj cute at all. That they have a regenerative braking. Whenever you're giving a brakes, there will be a dynamo generating electricity from there. Okay, that is a macro hybrid one. Okay, so in this plug-in hybrid, in Toyota Camry, what they're doing is like, in IC engine they are keeping a bigger alternator. So whenever it's going in highways, it will regenerate from the battery. Clear? Battery is recharged. That is called as a plug-in hybrid. Clear? This is an electric vehicle. This is a circuit of electric vehicle. This electric vehicle doesn't have any regeneration, because whenever a power source of a IC engine is there, then only you can recharge the batteries, because more power required to recharge the batteries. Okay, so electric vehicles doesn't have any recharge of techniques. Right now the technologies are coming into the solar vehicles. Whenever they are running in a highways, whenever the solar panel on a roof, if exposed to the sun, it can claim more than a full charge. If a full charge is there, which climbs around 200 km per hour, 200 km per charge, whenever you are running a vehicle for 200 kilometers, it can recharge around 12 kilometers. That is a conversion of solar vehicle. That's it. Not more than that, any conversion is happening in solar. Okay, so electric vehicle doesn't have any charging capacities and charging facilities as of now. Current trends. Okay, these are all electric motors, stored status, and right now, leave these hybrids, parallel series and things. Some of the questions right now I can ask to you. Please differentiate a IC engine and electric vehicle. What is the difference between electric vehicle and IC engine vehicle? Engine vehicle. Sir? Source. Good source. Next.
Efficiency will be higher.
Efficiency. Okay, sir. I'll explain about it. Efficiency is not exactly efficiency is higher. No, it's equal only. I'll explain about it. Next.
Eco-friendly.
Yes, sir?
Emission.
Emission, good. Emission, eco-friendly. But if it's carried in that cycle, then only it's efficient. I'll explain about it. About efficiency, I'll explain. Next. What? Range. RPM range. Yes, RPM range is differentiated. Good. Next. Sound. Okay, good sound. Next. What? Cost. Yes, cost. Good. Next. Sir?
Delays.
What's it?
Changing gear, delays.
Good. You're saying about torque. Good. Nice. Perfect. Really good. Next. It's like performance. Performance difference when IC. Right now, which gives a better performance? IC engine or electric vehicle?
Yes.
IC engine. Electric vehicle. I'll explain about this. Right now, first we'll test the performance. Any board markers? Any board markers are there? Ma'am? Fine, done. Thank you. We'll get a small into technical. Do you know about power graph? Power graph. I'll just. Okay, this is actually a torque and this is RPM. This graph is of IC engine, this graph is of EV. Any idea what I'm going to draw again? This is actually a performance differentiate between IC engine and electric vehicle. In IC engines, whenever you are going to buy a IC engine vehicle, you can see and note that at this RPM, this maximum torque will be attained. You have seen, like, just take an example of an electric bike scooter and an example of an electric two-wheeler, IC two-wheeler. We'll take it as a Duke and this side as a Vida. Everybody know about Vida, right? Hero Vida, electric vehicle, or else Ather, whatever it is, Ather. Okay. Duke 200cc engine, do you know how much torque it's producing? Any idea how much torque it's producing, Duke 200cc engine? At 8000 RPM, it produced 24 Newton meters. At 8000 RPM, it produced 24 Newton meter. Okay, that is a comparison. That is a IC engine one side. Next, we go for a Ather. Do you know how much torque it's producing? Any idea? If you keep a drag race between Duke 200 and Ather for a 50-meter drag race, which will win? Duke, sir? No, sir. No, sir. Duke won't win. Ather only will win. Why? Do you know the highest RPM of Ather? It can go up to only 3000 to 3500 RPM. It won't reach maximum. The maximum RPM of an Ather vehicle, 3 kilowatt motor, is just 3500 RPM. But why it can beat Duke? Why it can beat 8000 RPM, 11,000 RPM engine? What is the difference? Whenever it comes to the speed, Duke will be going, but whenever it comes to the torque, Duke is nothing. Any idea why electric motor is more performance than IC engine? Everybody know about torque, right? What is actually torque? Sir?
Twisting force.
It's perfect. It's a twisting force. If you are just, see here, I am moving like this, it's called as a linear force. If I am circulating like this, it's called as a torque. Twisting motion. Twisting force, twisting motion is called as a torque. To move a vehicle, what is required? To move a vehicle, each and every tires are round, right? So force, in which term force need to be? Sorry, in which term, yes. In which term force need to be?
Twisting.
Yes, it's a twisting force, torque. So to move the vehicles, because each and every wheels are rotatory, so to move the vehicles, torque is more required. A very good specifications and very good parameters are there in electric motor is like, even in 0th RPM, if it's going at 1 RPM, you can get the max. It's a IC engine circuit diagram, IC engine vehicle circuit diagram. You can just check about it. On top, parking lamp is there, headlamp is there, parking lamp, headlamp. From here, each and every lines is noted in different colors. See here dynamometer and alternator, which generates the electricity from a mechanical movement. Okay, and top it's a starter motor. From starter motor, from battery a connection is going, and a starter motor, from there it's grounded, and alternator is there. It's a working IC engine circuit. In IC engine itself, this much wires are there right now. In right now field, in IC engine itself, this much wires are there here. Flashlight sensor. That is actually flasher. That flasher is only helping the indicators to glow. Like on and off glow, on and off glow. That is actually flasher. It's not clearly seen here. That is actually wiper motor. This is actually a wiper motor. This is a flasher. This is a heater motor. Any idea why heater motor is used?
Not modify that source much because it will need further transformers and requirements because it is energy conversion system, so it has lot of specification and requirements. We will list out. One is efficiency. So efficiency is matters because we are transferring fuel from one source to another source. So leakage in the nozzle, it is not allowed. So efficiency should be highest because it is transferring energy from one source to another source. So efficiency matters. Then second thing is power quality. Power quality is the second problem. Power, because we are taking power from AC source and charging DC supply. So power quality issue will come. We will discuss the power quality issues. Power quality, power factor, THD should be maintained as per the standards. Challenges. And one more requirement that I missed, that is isolation. We need protection. It should be protected because the line will be hazardous. So isolation should be there. Without isolation, we cannot go for charger. That means non-isolated charger cannot be used because of the safety. So challenges are this. One is efficiency, that is a challenge, and second, power quality is the challenge, and isolation is the challenge, and size is also a challenge. Size requirements, we will need higher density converters because of the size limitations. And opportunities, that is a major thing, and opportunity for us. Okay, that is a main thing I am trying to discuss. Opportunity means what we can do in charging field. Okay, so in charging field there are a lot of works are done, a lot of works are going in different higher institutions and research organizations. Mainly in EV side, most of the work in India are charging side because it needs less standards than the automotive. Okay, so there are a lot of charger requirements. If we install a charger in our place, we will buy the charging boxes from China and we will install it. That's the thing happening nowadays because we don't have enough technology and product from India. It is very less. So we have a lot of opportunities because we are far below from the technology development. Far below. How much years we are lagging in technology? Based on our technology level, what will be the year difference?
10.
It was more than 20 before 10 years. Now it is not 30. I think it's more than 30 in some cases. In some cases, actually, before 30 years, if a product is existing in some country, we are not able to rebuild it. Including power system products, we are not able to build it. That is a challenge. Okay, so that is opportunity. Challenge is opportunity because there are spaces to work. Because we are lagging, there is space. If we work in some countries like Japan and Germany, it will be very tough because technology is very high, they achieved. So it is very tough to work there in Germany, Japan, and some technologically developed countries. So in India, actually, with simple technology, we can survive. Is it right? Okay. So there are opportunities that we can utilize that opportunities by building technologies, by achieving technology standards. We can utilize those opportunities that I am discussing. EV charger blocks. We will go inside technically. EV charger blocks. I think most of these things are available, but I am just making a discussion only. This is the basic block of a charger. This is single phase charger. Input is taken from the left side, and there will be filter. We will discuss more about filters. There will be filters, especially high frequency filters, to avoid interference EMI towards the line. So there will be noises because of the switching. It should not be transferred to the line because it will make disturbance for other devices and power system. So power filter will be there, and AC-DC converters. Normally in schools we learn about rectifiers. From the school we learn about rectifiers. Yes, is it right? So what's the purpose of rectifier? AC to DC conversion. By using a rectifier, AC can be converted to DC, and by adding a filter, we will get a smoother DC voltage. But for power application, it is not usable because it will make lot of THD towards the power. So it is restricted for very low power applications.
Triple harmonics. THD.
THD. That harmonic, total harmonic distortion.
Low power application is up to
We'll
1
discuss.
kilo. Up to 1.
I'll discuss standard actually because IEC standards, for IEC different A and class different standards, up to 100 watt we can use some rectifiers to 100 watt only. That is IEC class D. I'm not expert about that anyway. So IEC 6000 series in class D, we can go up to 30% of THD for the third harmonic, only up to 100 watts. After, it should be 5% THD. Now it is close to 3%. Standards will change. Okay, so THD should be limited. Because of that, we cannot use rectifier directly to convert AC to DC for the power application. Okay, we'll discuss. Actually, there are slides. So AC-DC conversion is challenging one. Without disturbing line, AC should be converted to DC. That is the power quality matters. Okay. And DC-DC converters. AC will be converted. I will share the values. Suppose supply is 230 volt AC. AC-DC converter will give 400 volt. That for the convenience, AC-DC converter will give 400 volt DC. That should be converted to EV pack, either by increasing or decreasing, depends on the battery voltage. Suppose if it is a scooter, it can be 48 volt or 50 volt. So the DC-DC converter will convert that voltage to 400 volt to 48 volt by having an isolation. Without isolation, we will get electric shock. So there should be isolated converters, just like transformers. Okay.
Actually, the input of the DC converter is around that 230 volt range.
It will be up to 400 because the AC-DC converter will be boost type. Normally, it is most simpler is boost converter. So it will convert the 230 into root 2 325 to 400 volt. Normally, rectified output will be 325.
Yeah, 300.
So it will be boosted up to 400 volt because it needs some boosting margin. So it will keep up to 400 volt. Normally 400 volt is the standard voltage for single phase supplies. Okay. Okay. Then 400 will be converted to down to DC, again DC with an isolation. If suppose battery, even if battery is 400, there should be isolation.
There we go for the conventional converters like push-pull half.
Yes, we can discuss. But efficiency matters in the case. Okay. Push-pull can be used too, sir. Okay. Okay. It is exactly similar to a laptop power supply, laptop charge and basic charger. Everything may be inside that, but AC/DC in AC/DC converter for the laptop charger, AC/DC converter will be simplified. There will be simplified rectifiers because it is less than 100 watt. Normally laptop chargers are having power up to 60-65 watt normally. More than that needs power quality corrections, PFC. I'll discuss more about the AC/DC conversions. Okay. Initially, all of us used AC/DC. For AC/DC converter, we used rectifiers. Normally, we used half-wave rectifiers and full-wave rectifiers for different applications. Depends on the complexity and power requirement. These are the approximate waveforms with the filter. The black thing in lower side, the black waveform is the DC output with a small ripple. Okay. Then the dotted line shows the rectified output without filter. So only the increasing part of ripple will take the current. So current taken will be in smaller region. I'll show it. This is the problem. So I'll give the waveform. This will be the approximate voltage and current waveform of a rectifier. For the simplicity, in initial days, initial labs, we will skip it. Initial lab experimentation, we will not take current waveforms because we don't have facility for taking current waveforms. Normally, current probe will be not available. Okay. So this is the current waveform and voltage waveform for the rectifier. This is not allowed for higher power applications. Only lower power application, this thing can be used. So we will need AC/DC conversion with PFC because it will reduce power factor. We'll have slides. Power factor. Actually, what is power factor? Give 53 to the 43 volt battery. Current will be very high. At that time, CC will be acting. CC will regulate the current. CV will be coming when it is charged to the full level. If suppose battery voltage is close to 52 and 51, the 53 will be the charging voltage. Only small difference will be there in
That
CV.
time it will only CV.
Yes, sir. Initially it will start from CC because that is safer. After achieving certain voltage, it will go to CV. Just like you said, it will be like floating charging system. Okay. So to achieve the voltage and current, that should be enough control. So the converter should be wide range operating type. Suppose if we design a boost converter. Normally we start with a boost converter. We designed a boost converter for 1 kilowatt. Up to what power we can operate? Up to what will be the minimum power that we can operate? Suppose we designed a converter for 1 kilowatt. How much power will be the minimum power? What will be the minimum power rating of that converter? How can we decide? Depends on the design. So we have to take the lower power also for the design. Suppose if I need to operate that system for 50 watt, we have to put more inductor value to make it CCM. The converter will be bigger. So if it is wide range operation, converter design will be complex. Suppose I am asking for a design with a power rating of 1 kilowatt and I am demanding it should operate up to 10 watt. So it is close to 1% of maximum power. It is very tough to operate that converter in 10 watt. So wide range of operation is very complex in Powertronics design. So for wide range operation, just like once if we charging a vehicle on charging point, if we watch the charging status, we can see up to 90 or 90% it will charge fast, very fast. After that, the system, the BMS will send commands to reduce the current. So we can see the current is reducing. It will reduce the current, but at that time it will keep the charger for longer time for the safer operation. That means just like mobile charging system, after 80% charging will be slow, after 90% is very, very low, to make the battery safe. That means for higher rating, higher SOC, the charging rate will be very less. Suppose 20 kilowatt charger operating at 1 kilowatt, what will be the efficiency? If we designed a 20 kilowatt charger, it is operating at 1 kilowatt. How much efficiency can be expected? Efficiency curve will be like this, like a hill. It's not flat. Efficiency can be achieved only at rated power. At lower power, efficiency will be decreasing. At lesser power, efficiency will be very less. It is operating for longer time because it will take more time to charge the small region because it is charging at lower rating. So efficiency curve is important for the converters. So normally efficiency curve will be like a hill. So for lower power operation, we need to arrange some other features like burst mode charging. We can turn off charger for smaller time. Like that, we have to go for some methods to avoid the efficiency decrease. So there are a lot of challenges when we have a wide range operation converters. Okay. This is an LLC converter. We started with a converter. It is known as hard switching converters. It is running with a square wave. Square wave, what will be the frequency components in the square wave? If we put FFT on a square wave, what will be the result? Infinite number of harmonics will be there. Ideally, a square wave contains lot of harmonics, infinite number of harmonics. That means it is the collection of harmonics.
All out of them.
Yes, so lot of harmonics will be there. So square wave is not preferred for the efficient application. So for efficiency, the hard switching converters are not suited. So we have to go for a soft switching converters. The wave should be sinusoidal. That is known as resonant converters. Okay, so this is LLC resonant converters. It is having two inductors and one capacitor at resonant path. These are the thing that is known as LLC converters. One capacitor is the resonating component and LM is magnetization inductance of transformer, and we added a capacitor in series the path. This is the simpler converter used for power up to 2 kilowatt only. For higher power, we have to go for higher type resonant converters. This is LLC converters. We can start a charger with this one. So we have to build an LLC converter. LLC converter runs in a frequency within the resonant range. We use resonant curve in the pulse width. Okay. Normally in switching converters, to regulate output, we will change the pulse width. But in resonant converters, there is no provision to change the pulse width. Normally pulse width will be 50%. So how can we control output? Pulse width cannot be controlled. So to control output, we use the reactance property of either L or C by changing the frequency.
Frequency of the switch.
Frequency will be changed. That is LLC, here LLC characteristics shown. We will change the switching frequency to regulate output. The switching frequency can be either greater than the resonant frequency or less than the resonant frequency. Normally we use the switching frequency greater than the resonant frequency. This is the curve with different Q. Q means when the load changes, the Q will be changing. That means with different loads, the curve will be like this. That means only thing we need to understand, if frequency increasing from this point to this can be a safer point, and from this point to that point output is reducing with increasing frequency. That means if we can increase the frequency, we can reduce the voltage. Okay? Gain is fully depends on the reactance, that is inductive region. There is two regions for resonance. One side is capacitive region and second side will be inductive region. We use normally inductive region which reduce output with increasing frequency. Okay? Because its impedance will be depends on the frequency and EV charger. Up to 2 kilowatt we can go for LLC converters. For higher power we have to go for converters like CLLC or full bridge converters like that. Okay, is it clear? This is isolated converters, but it is switching sine wave rather than square wave. Normally we are using square wave converters for normal low power application. It will generate lot of noises. If we build a converter without a proper EMI design, if we switch on the converter here, the computer in within 4 meters will get hang. That will be the noise, EMI noise. To reduce EMI noise and better efficiency, we can go for resonant converters. So there switching power conversion will be within the higher frequency, resonant frequency. So the loss will be less and EMI will be very less. Okay. So this LLC converter. This is the characteristics. The slope is used to control the output voltage. And this is a basic technique for LLC control. We will have generation, pulse generation. There will be variable operating frequency control generator. It will generate variable frequency, then it will be controlled by PI regulator. Normally duty cycle is controlled by PI regulator. Here frequency is controlled by PI regulator. Is it clear? Okay, frequency is controlled by control loop. There is a plant these controls current protection devices. Okay, so there will be our current protection devices. Actually for LLC that is highly efficient, but basically LLC is limited to smaller power region. For wide range operation we need to give some protection measures, otherwise LLC will get damaged. Okay, so there are a lot of LLC controller chip are available in the market. In our last product we have used LLC controller device from Infineon. I'm not remembering the part number, but we used LLC controller both from Infineon and Texas Instruments for controlling LLC converter. There are enough features to control and regulate voltage and to protect the converter. Okay. Okay. This is phase shift full bridge converter. This is the next version that is having more power capacity. It is called as PSFB, phase shifted full bridge converter. It is having a full bridge on front side and a rectifier on right side. The conversion will be controlled by phase shifting between two legs. That is called as phase shifted full bridge converter. Pulse width will not change, only phase shift will change. Just like inverter, phase shift will be changed. If it is in phase, output will be 0. If some phase shift is there, output will be produced. So output can be controlled. That is dual active bridge. That's DAB. Nowadays we are discussing about bidirectional chargers. The charger is capable of giving energy from the battery towards a grid, that is called as V2G. In future, vehicle can give power to the grid. How it is possible? Not technically. Will we allow to give power from our vehicle? So, will it work? How? Actually, we have a limited capacity battery.
And draining the battery.
Yes, sir. Because battery will get drained. Just like a water tank, it can give water towards the water authority. Will we allow it? But we'll allow if we get much cost than we charge. In daytime, if we get energy at 5 rupees, if we get cost of 15 rupees for the export, we will export up to certain percentage. The battery can be utilized as a localized storage system. And one more thing, for reactive power compensation, the system can contribute to certain percentage by giving reactive power. So power battery will not get drained, but system can support reactive power. So that is another feature of V2G. So V2G will come if sufficient reward system will be made for the user. There should be some meters.
But I think it is there in Bangalore Metro.
Yeah, yeah. I think it's not implemented in India, I think, but I'm not aware. But actually, Nissan regulations are not there. Actually, there should be meters that is giving rewards for us. Suppose it should work. Actually, there are things technically, including Nissan Leaf and some cars are already equipped, but electricity boards and government should make some standards to promote it. Okay, that is V2G. For V2G, for DC-DC converter should be bidirectional. So in this case, there will be two bridges that is called as dual active bridge. First one was single side bridge. Second one was dual active bridge. That is most promising thing nowadays because bidirectional energy flow can be achieved. That is dual active bridge. Actually, we are working on some smaller projects in DAB for the battery charging and discharging operations, including some things like hybrid inverter. Now it is time for hybrid inverters, hybrid solar inverters. So battery should store energy in daytime. It can export energy in night time. So that is possible by bidirectional converters for the battery. So it may be achieved by the dual active bridge. So